Okay, so I want to discuss universals and particulars, particularly my theory regarding them. Um, so, in graph theory, there is a concept known as the minimum um, semi-definite rank, and to my understanding, it's basically the dimensionality. It corresponds to the dimensionality of a graph. Basically, in how many dimensions can this graph be represented? Um, so if you have the MSR, minimum semi-definite rank, of a graph G, MSR of G, then this value is less than or equal to the number of nodes of the graph minus Z. Z is known as the zero forcing value or vector, I think. Zero forcing bound, I think. The the Z value is determined combinatorially, um, which uh, I know how to do, and others know how to do it. It's not too terribly difficult. I'm not going to get into it right now. So you find the Z, and you know how many nodes n are on the graph, and so you can get a boundary condition. Sorry, you can get this bound for. Well, I guess you can get this upper bound for the graph. So it's how many dimensions at most can this graph be in how many dimensions at most can this graph be represented? So if you have a tree graph, say of two nodes, then the zero forcing number, Z value, is going to be 1. Um, and so in how many dimensions can this graph of two nodes, basically a straight line with two nodes at each end, be represented? Well, n is 2, z is 1, 2 minus 1 is 1. So your MSR of G is less than or equal to 1. Well, it turns out, yes, you can represent a line in only one dimension. So yeah, MSR of G in this case equals 1. The dimensionality of the graph is 1. A line is a one-dimensional figure. Very good. That's all there is to it. Um, and well, what about then a single node, right? A point, as it were. Well, I guess Z, if it even really makes sense to do it, I would conjecture that it is. The Z, I guess, would be 0, and you have one node, so actually no, it would have to be 0. But you have one node, so I guess Z would have to be 1 because a point is dimensionless, so 0, right? So I guess Z would have to be 1. That's odd, isn't it? Yeah, so that's probably you probably can't do that. There's probably something in the definition of Z that prevents a single noded graph. Anyhow, but the idea with universal particulars is using this concept of minimum semi-definite rank and graph theory, and this combinatorial procedure to find Z, to perhaps determine a limit for n. How many forms are there? If we know how many particulars there are in the universe, which presumably is a countable number, we should be able to figure it out, because we can perhaps theorize, and I guess now there's going to be this metalogic conversion between graph theory and metaphysics, but we can perhaps conceive of the required dimensional structure for such a graph of the forms, the Platonic forms. If we have all the particulars enumerated, and we know that each particular must correspond to at least one form, I would actually argue at least two forms, then you should be able to figure out n. No, maybe not, because you can't really find z. Well, you could put boundaries on z, but I'm not sure that would actually solve anything. Well, maybe not. Okay, so if you want to find the dimensionality of the graph, suppose you have a finite universe, a finite number of particulars. Each object is a particular and corresponds to at least two forms, namely the form of the particular itself. You know, let's say you have some particular that has only one property, say red. No, you can't do that. That would be a universal. Suppose, I guess, in modern physics parlance, you have a tension of a string is the only and absolute constant in the universe. The tension of a superstring. So that would be an example of such a particular if that would be a particular. It's a property of a string. So it would actually be universal. Okay, so let's say you have a superstring. This superstring has only, it has two properties, tension and energy. It's comprised of energy, it's a string of energy operating at some tension, oscillating at some tension, with some tension. Okay. So to actually do it, I'd have to sit here and make a list of all the properties of strings and what have you. But suppose then, hypothetically, there's an atom, a very, the Hellenistic atom, the absolute smallest indivisible substance of matter. And let's say there's the atom of the table, and let's say the only property of this atom is that it is red. So there's the atom, the red atom. There is a red atom, and that is the only property of this atom other than being an atom. So there would correspond to that the form of the atom and the form of red. Okay. Yes, there are issues with trying to rationalize the concept of the form of red. I acknowledge this. For now, I'm going to overlook that. Let's suppose that it's a thing. Or, let's suppose that the universal of red is a proper universal. It is allowed in the system. There are no issues with it. It makes sense. Let's just assume this. then I suppose this atom has to have these two properties, the form of atom and the form of red. But then it's also going to have, and this is what I was trying to get at, the third form in this case of informing. There is the relationship so I think for every verb there is a corresponding form. There's the form of up, the form of next to, the form of across from, the form of actually, and perhaps you have equivalent forms. Perhaps the form of next to and across from is the same thing. Maybe it's an equivalent form, and that's just our human mind, perceiving it differently, and so we abstract two different terms for what is really the same form. In this sense, I guess you kind of solve the whole relativistic issue. Is the chessboard on top of the table, or is the table underneath the chessboard? Well, yes, different terms for the same relation. Is the chessboard on top of the table, or is the chessboard next to the table? Again, yeah. If I were to turn my worldview 90 degrees, it's the same thing, but with different terms. If you allow for this equivalence of formal information, then then perhaps you have several forms that are all really equal, and there's really only one form that branches to these various things. So I think then it's possible that you have forms of relation. And so there is the form of informing, because the form informs the particular. Would there be the form of informing? Or would there be no such need, as it would be an intrinsic property of all the forms? But see, in this sense, the forms behave like particulars. And so I think there is the form of informing, because in this sense, then, the forms have the property of informing, but then they're predicated, and so they are particulars. I have as an axiom in my system, I should probably make note explicitly, that to be particular is to have predicates. To be a particular is to have predicates. So, if the form informs, it has the predicate of informing. And so it behaves as a particular. And so I think you have this hierarchy of forms and formal information. And at the top of that hierarchy, there is the form of informing. I have considered, and I acknowledge that this can seem kind of like a Russell paradox, it kind of may start to seem like a set of all sets. The form of all forms, this uber form, the form of informing. Well, that form has to relate to itself. It has to have the form of informing, to inform the forms to inform. So if you have a particular, a material object, we'll say, this atom, this hypothetical atom of ours, and you have a corresponding form of that particular, you need the form of informing to inform the form. All right, let me use variables. So you have a particular A, P. A, and then it's a particular, so A sub P. Then you have the corresponding form, A sub F, for form. Okay. So, then you have AP and AF, and you have the form of informing, which has to inform AF, so that AF may inform AP. This starts to present an issue because the form of informing, we'll call it FI, has to inform AF, which is now kind of behaving like a particular. But in order to do that, it needs to relate to itself or have another form of informing to relate to it, so that it may inform the form, which is now a particular, to inform AP. And so you just get this chain either ad infinitum, or you have to have the form inform itself. If it continues on ad infinitum, then this is a problem for my graph theory. The form of informing so I don't suppose you could have a form of informing and informing itself. Or unless that would be implied in being a form of informing. Being a form of informing implies informing yourself. I guess that would just have to be another axiom. I don't like it. I don't like that. I don't like that. That doesn't really... That's kind of just this Lactosian ad hoc kind of hypothesis. we have this problem, so we're just going to fix it with this. It informs itself. No, I don't like that. So... if you have, then, this form of informing, it would have to relate to all other forms and particulars. Or, no, it would just have to relate to the form. Right. But then, okay, so let's just suppose you have this one thing. We'll deal with the infinite regression or whatnot later. So if we have this form of informing, it corresponds to the form AF, which corresponds to the particular AP. Okay. AF then corresponds to AP, and FF, the form of informing, corresponds to, it would appear, not only AF, but also AP. The particular now has the property of informing. Because we can look at a particular and abstract the form. So the particular must have the form of informing. And herein lies the solution, I suppose. There is no infinite regression of forms of informing because this is identical, this is equivalent, this is an equivalent relation to the form of abstraction. That could be. So now you have this, it's itself. You have the form of informing the form of abstraction, which is informing itself, so it goes back and forth. That could work. That could work. And actually, that's good news for the graph theory idea, because then you have two nodes. You have two nodes informing themselves. So basically, you have two nodes, and to each of those nodes, you have at least two vertices connecting them. Okay. I think I'm going to have to diagram this. So I'm actually going to go to the university and borrow a blackboard. And I'm going to actually diagram this out. Maybe, try to figure out a solution.